14th of August, 1957. The first of some 200 men began to move into a former research center, recently leased by Chrysler Corporation at 403 Midland Avenue in Detroit. These men had been completely detached from their current jobs and assigned to a project known only as Project A901. For months to come, Project A901 was to be the most closely guarded secret in the automobile industry. Beyond the task force of engineers, designers, draftsmen, and technicians that was converging on the building at Midland Avenue, only a handful of key corporation executives knew this secret. Among others at Chrysler, rumor had it that this was a top-secret weapons system project for the Department of Defense. Others had it straight from someone who knew that work was underway on a revolutionary new chassis design for corporation cars of the middle 60s. There were other explanations. All of them were wrong. One man who knew and had known for some time the truth about Project A901 was Jack Charapar, Chief Engineer, Director of Product.
Project A901 was not new. Many of us had been involved in it since early 1957, or at least the work we'd been doing had the name A901 since then. The work itself had been going on longer. In a sense, it had been going on for decades. When we moved into 403 Midland Avenue, we were on the last lap. The mission of Project A901 and the goal of the 150 men of this design development task force, and some 600 or 700 more in central engineering, was to create a new car for Chrysler Corporation. An entirely new car. In design, in styling, in concept. An efficiency car. A new package concept in personal transportation. This is what we were starting with, quite literally. An absolutely clean sheet of paper. This is a chance that doesn't come very often in our business. Every member of the task force looked on it as a dream come true. However, even though we were starting clean, we had a long tradition and an invaluable pool of experience to draw upon. The technical tradition in smaller cars at Chrysler begins way back in 1933, when we were experimenting with the first prototypes of the famous airflow lines. At that time, along with the larger Chrysler airflow and the DeSoto airflow, we not only designed and developed, but built and tested the prototype of a smaller airflow. It's a matter of history now that the airflow cars were not successful with the public, although technically they were brilliant automobiles, far ahead of their time. They were among the first cars ever to be designed along aerodynamic principles. They had unitized bodies, an important Chrysler first in America, some 20 years ahead of the industry. Small car experiments continued on through the airflow program, through the 30s and 40s, right up to the war, with a series of cars of various types, many of them quite radical. In 33 and 34, a rear-engine car was developed and discarded. Its power plant was a radial six-cylinder diesel. Around 1936, the prototype of a car called the AH was built and tested. In 38 came the AW. After the war, this program continued. The Chrysler Cadet was one of the smaller cars designed, developed, and actually ready to move into production in the 50s. However, all studies of market trends at that time indicated that the public was not ready for its introduction. By 1954, at the very time when the cars on the market were beginning to grow bigger, longer, heavier, and more powerful, the experimental work on smaller cars was accelerated. The time was obviously coming when the American public would be ready and eager to buy a car of luxury, comfort, with easy handling, designed to be compact and economical. One that was smaller, lighter, and didn't have to cost as much to buy or run. Chrysler Corporation was determined that when the public was ready, Chrysler would be ready. The value of this big backlog of technical and styling experience is immeasurable and hard to describe. Specific design details grow obsolete pretty fast in this business. 6 months could be a generation. Yet all through the years, we were gaining experience in dealing with package concepts, like seating arrangement, structure, chassis layout, and styling. with component design for power plants, suspensions, brakes. It taught us, among other things, the fundamental soundness of ideas such as unit construction and aerodynamic styling. In the 50s, a minute fraction of our market was turning its eyes on the products of European manufacturers. Chrysler Corporation undertook a vast, exhaustive survey of all the European car manufacturers, their products, engineering, production facilities, and the national economies in which they were produced. In the middle 50s, focus sharpened. There were indications of a changing public attitude in 1956. Early in 57, a special car committee was formed at Chrysler Corporation, representing each of the corporate staffs: engineering, finance, manufacturing, and sales. Its mission: to establish a set of design objectives for the creation of a new, high-efficiency automobile.
These were the goals that were set. The new car would have to be fully competitive in utility. Capacity could not be sacrificed. In performance, Americans demanded a lively car. In styling, no stripped car or scaled-down version of an existing car would do. New proportions, new themes had to be found to set the standard. In comfort, in reliability, in durability, in safety. In all these categories, the proposed new car could give nothing away to any possible competition. But there were further demands. In 3 areas, it had to be more than competitively acceptable. It had to be outstanding, better than anything that had come before. Outstanding in low initial cost. Outstanding in low operating and maintenance cost. Outstanding in controllability, a word which covers handling, parking, acceleration, cruising, everything a car does when it moves. With these concepts frozen, work began on assembling a task force that could meet the challenge.
That was quite a list of specs to live up to. This task force that was handed the job was made up of representatives from the engineering group, including design, experimental buildup, testing, and from finance, market analysis, manufacturing, and styling. A top-flight chassis design coordinator found himself shifted from his work to this super-secret project. An expert on suspension from one part of the corporation, a top man in axles, another in engines, another in transmissions, the best talent that the corporation boasted in styling. These and many more were actually physically moved from their different departments and assigned to Project A901. This was not only for security reasons, but also for reasons of inspiration. They started work in an atmosphere completely isolated from other Chrysler Corporation engineering and design. Their only job was to produce the A901, and the A901 had no connection with any car of any other division. We built it from the road up. One of the first design problems was the basic layout. This was to be a family-sized car. The layout would not be acceptable unless it could hold, comfortably, a family of 6, have plenty of space for their luggage, and room for a power plant that would move this load economically, but with good performance. In arriving at the basic body structure, a tool of Chrysler missile science became an important design and development tool. The design of even such a simple item as rubber engine mounts, for instance, involving 6 separate directions of vibration, calls for some 300,000 separate calculations for each direction. What would take a man at a desk calculator hundreds of years to do was completed by electronic computer in only seconds. With such a revolutionary approach to analysis, years of engineering progress were almost instantaneously available. We were able to take 7 league strides into the future. Other methods of structural analysis were developed. The plastic scale model was one. Using this replica technique, we can determine how all parts will act under actual performance conditions by imposing bending and twisting loads on the model and measuring the deflections of each part as the model rolls down a theoretical road, all before we've built the full-size body. This was particularly important since the decision had been made that A901 would be a car of fully unitized construction. Instead of a body bolted to a frame, body and frame are one welded metal unit. The sheet metal of the car is working metal, complete structural skin. This was engineering's answer to the original design concept of creating a structure that would enclose no excess air, of using the least amount of space to get the biggest amount of usable car interior space. The result has been a car structure that is safer, quieter, more durable, lighter, with more room inside for people and luggage, and with a smooth underbody for low aerodynamic drag. We had designed and developed a body with all these desirable features. Now we had to make certain that all this beautiful structure and skin would stay beautiful for a long, proud lifetime of durable service. The secret lay in developing a system of corrosion protection, which would prepare the steel in the body to receive the various external finishing operations by cleaning it, cleaner than steel had ever been before, absolutely chemically clean, from the steel mill to the final assembly, so that the special paints which were to be applied would marry with the surface forever. In order to assure positive cleaning and painting of every inch of body metal, inside and out, we designed a system of 7 huge dipping vats, bigger than swimming pools, in which the body could be submerged to receive successive cleaning and priming treatments. The body is simultaneously dipped and sprayed. It emerges wearing a final coat of a new paint called emulsion primer, better at resisting rust than anything we've ever seen, ready for the finish color coats of luster bond synthetic enamel. Unit body construction is inherently quieter than traditional car design, but we set about to make it even quieter by applying special sound insulation materials at all critical areas. Large amounts of rubber were also used to isolate engine and road noise. Sound and vibrations were isolated at such critical spots as the rear spring mounting, the front suspension arms, the power plant, and the exhaust system. So very little noise was transferred to the car itself. In the sound lab at Central Engineering, component panels and assemblies were studied to discover the different natural frequencies at which they vibrated. Then, every panel and part in the whole body was actually tuned, like a piano. In this dynamic structural tuning, the different frequencies were made to cancel each other out. Or parts were isolated from vibrations which might cause them to make noise. Or the natural vibration frequencies were actually changed so the panels would not respond to vibrations most likely to get to them. All this time, others of the 15,600 separate pieces that were to go into the A901 were being designed, also from a clean drawing board. For the new car was to share nothing with cars of other divisions or other model years. Engineering and styling throughout the project were hand in hand, particularly in overall body design or seating comfort, but also in many other details. On the grille design, for instance, distinctive, youthful, and with a feeling of power and performance. The look of this grille is not, however, only a styling detail. It was scientifically arrived at as the best shape which combined maximum cooling efficiency with minimum aerodynamic drag. Not only were we designing this car fresh from the road up, but we were also designing it from the inside out. Comfortable riding space for a family of 6, remember, was our most vital yardstick. Here in the design of the doors, we gained from unit construction. This is the door of the A901. Thin, without losing strength. It's designed like a hatch in an airplane fuselage, so the lower door does not have to be fat to take the window when it's rolled down. The upper body and glass planes flow down smoothly into the body in one continuous line, turning under at the bottom. Compare it with conventional door design. Throughout the car, a constant goal was to save metal and space, to give not 1 inch or 1 ounce away to past convention. What we could save in weight and wind resistance had a very real bearing on the power plant that was being developed. For we'd been handed a really tough challenge in this department. The new car had to come up with 2 qualities that have always been difficult to achieve by either American or foreign car makers: outstandingly agile performance and top fuel economy. The task force turned again to the electronic brain for help in study and analysis of engine possibilities. We fed into these tapes, which are the memory of the computer, thousands upon thousands of facts. Data relating to chassis efficiency, weight distribution, load, acceleration, handling, aerodynamic stability. In effect, we were able to test run and compare many different kinds of engines in different positions, all in theory, before we built a thing. We analyzed air-cooled engines and liquid-cooled ones, front and rear engines, 4 cylinders, 6s, 8s, Vs, flats, radials. And then we built one, a new one, the right one for this new car. This is it. But before we take a look at it, let's see why we put it where we did, which, as you can see, is in the front. It's in the front because a front-located engine is the simplest, most effective way to obtain inherently stable weight distribution for good road handling, maximum passenger seating, and comfort, and luggage space. And it's the only way to achieve modern station wagon design. The front engine also permits the selection of the inline liquid-cooled engine with all its advantages, particularly quiet operation and good winter interior car heating. Further, it makes short, rigid controls for transmission and engine possible, without the need of special tunnels in the floor for such controls. With it, simpler, more rigid car structure is also possible, because it positions the largest single weight in the car forward, ahead of you. With the fuel tank at the rear, you're safer in this car in the event of a collision. This brand new engine, efficient, economical, and raring to go, is a water-cooled, inline, overhead valve 6, but as you notice, with a difference. It is tilted 30 degrees from the vertical. Because of this fact, we were able first to relocate engine accessories so as to shorten the engine compartment and gain more interior room for front seat occupants. We could reduce the hood height of the car. We obtained a lower center of gravity, which improves handling. And very important, it gave us for the first time space to use a new, different, and more efficient kind of intake manifold. This manifold has been designed with 6 long branches, almost equal in length, to bring uniform air-fuel mixture to all cylinders. They are made of aluminum so that they dissipate heat and keep the air-fuel charge cooler, which makes for more efficient use of the fuel. To keep down weight, aluminum gets a pretty extensive workout in this new engine, and more ways of incorporating it into the design are being studied. You find it in the water pump, water outlet elbow, the distributor, the clutch housing, and the gearbox and torque converter housings, an extension of the all-new 3-speed push-button controlled A901 automatic transmission. It's also used in the alternator, which is something new in standard production automobiles. It's been used before in special installations on police cars, trucks, and taxi cabs because it's more efficient than a generator, which often does not give enough output at low speeds. The alternator will charge 10 amps even at idling speed, and thus give longer battery life as well as improved battery condition for easier starting, even in the worst weather and slowest traffic. This overhead valve engine is a short-stroke design with a deep skirt block, an extremely rigid crankshaft with large overlap and generous bearing areas. For efficiency and high performance, the cylinder head features 12-port construction.
At this stage, some months before there was a prototype of the new car to put them in, engines and other components were rolling up test miles by the thousand. Cloaked in the shells of 1- and 2-year-old Plymouths, they clocked hours of rigorous performance tests per day. By the time A901 was ready for production, these test miles had rolled up to over 2 million. Work on this hush-hush fleet was already showing one significant byproduct of the new inclined engine design. For service, access to almost every part is easier than it has been for years. Mechanics had already dubbed it a serviceman's dream. Test fleet odometers ran into 6 high digits as axles, transmissions, suspensions were continuously punished with bigger car loads and stresses, far beyond any they would have to deal with in the new car itself. With the proven superiority of Chrysler's Torque Flight for a springboard, a new low-weight transmission was designed. A 3-speed automatic transmission that for the first time brings weight down below conventional manual transmissions. Suspension experts adapted torsionaire to the new car with results that outstripped their own uncompromising aims. The fully unitized body and very favorable weight distribution of the new car combine with torsionaire to give an unusually flat ride, free from dip or sway. A new and highly efficient steering system was developed. Known as trailing Pitman arm design, it is a fast-handling, low-friction system with steering effort that's uniform from lock to lock. While basic design elements were tested, adapted, frozen, styling of the A901 was moving forward. In this car, more than in others of recent years, styling became inseparable from design. Here there was no need to add character to the basic machine like icing to a cake. Character grew out of the design itself. Styling became an expression of its structural demands. A way of tying together and saying in three-dimensional surface steel everything the car was built to do. The engine's position set the height of the hood. A strength member in the unit body is responsible for one of the most tailored roof designs in a generation. Aerodynamics created the curve of the side. An automobile designed to be all automobile. This was not only a guiding philosophy for the men who built the car. It is a statement the car itself makes. A statement in steel, in glass, in trim, in its total appearance. By now, production deadlines were closing in. Even as some body components were still undergoing laboratory tests at Central Engineering, tool designers were working side by side with the engineers at 403 Midland Avenue. In some cases, the manufacturing division had tool designs ready simultaneously with the design of the component itself. Enthusiasm, never in short supply on Project A901, intensified as the spring of 1959 arrived. And still there was no security leak. Still, very few people outside the task force knew what the enthusiasm was all about.
We had good reason to be excited. In about half the time it was reasonable to expect results, we were getting results. And we had reason to believe that the A901 would not only measure up to every objective laid down for it over 2 years earlier, but that it was actually going to surpass most of them. In the areas where acceptably competitive levels were demanded, it was more than competitive. Where it had to be outstanding, it was outstripping the specifications. It's not far-fetched to assume that one reason for this stems from an ingredient never laid down on paper: the enthusiasm of those who put more than 1 million man-hours into creating this automobile, their determination to make it a totally new and different car in the finest traditions of Chrysler engineering and styling. One thing is certain. An amazing thing happened at Chrysler's proving grounds one morning almost a year ago. The first handmade prototype was ready. At this stage in the game, no matter how much is hoped for, nobody ever really expects things to go off without a hitch. There are just too many details, too many final adjustments. This time was different. For the first time in the careers of many watching, a prototype ran smoothly, without bugs, right off the drawing boards. That same day, 4 key test departments signed off on the project. Their work was done. After prototype number 1, the summer months saw 32 cars in all involved in the testing schedules. There was plenty of work still to be done. The problems of production were only beginning. Programs of marketing strategy, promotion, and advertising now went into high gear. But the work of Project A901 was essentially complete. It had given birth to a new kind of automobile. It had created Valiant. It was up to others now to sell Valiant.